Hey guys, how you guys doing? This is your Shiva, and let's quickly learn about what is JDK, what is JRE, and what is JVM. JDK is nothing but it's a simple software development environment which is used by our developers like us to develop our Java applications. Okay, it is a package basically which provides a lot of different you know tools. Using that, we develop our applications. Some of them are JRE compiler, Archiver, and Javadoc. Say this is my application, which is just printing hello world using this display method using a greeting object. Here, what how does that prints? What happens internally, right? First, whenever you run Java C class name, right? When you execute that, what it does is it calls the compiler. Okay, it calls the compiler and it execute that your class and convert that into bytecode. Hey, actually you can also if you don't want to use compiler, you start writing your code in a bytecode format. But don't try, you can't do it. Okay, it's not easy. Okay, so that is the point. So once you create the bytecode, okay, the philosophy of Java is can be achieved by using a bytecode. The what is the philosophy of Java? Java is write once, execute anywhere. Okay, that can be achieved using the bytecode. Okay, how can I achieve that? Because none of the operating system understand bytecode, right? For that we need a machine. How can I get a machine? Right? Java developed a machine for you guys. Okay, which is nothing. They created a machine which runs on top of your operating system. It can be any operating system. It can be like Windows, Linux, anything like that. Okay, where we call that as a Java virtual machine. Which is a machine, it's like a Java virtual machine. What it does is it actually takes your bytecode, converts it into a machine understandable code, and execute that. It actually loads. It have its own memory structure, and based on that it executes and all your application and everything, and it can run in any OS. Okay, interesting, isn't it? So let's quickly learn more about JVM. How can JVM able to do it? What is the memory structure of it? I want to know more about it, sir. I'm here to explain you, bro. Okay, so JVM basically having a first, what it does is JVM. Now we know that we have a bytecode. The challenge is we need to convert that into a machine understandable code. How to do it? Simple. JVM have something like a class loader, which actually loads your bytecode, and it actually runs the code where it puts all the class data, right? All the class information in the class area, and all the objects that you created, right? Greetings object stored in heap area, and the stack. Or say for suppose once you're like once running, say it creates a thread, all the thread data is stored in the stack, and the details of that thread, say the counter and all those things is stored in the program counter register, piece register, right? And say for suppose your compiler needs some kind of internal details, not internal details. Say for suppose compiler needs some kind of a native C++, because it's running in OS, bro. Okay, if you need some kind of that kind of details or things like that, we get them and put it here, right? And so that JVM having everything to run um, on the OS, right? So that's about it. And once this have all the things ready, it put it in this memory, and this is ready to execute. And this uses this, and it uses the execution engine. Using this execution engine, it executes the code. Okay, that's it. That's a beauty, right? See, it's like it have its own memory. It gets all the details. Boom. Okay, let's quickly see a step further. Say this is the code. This is the memory area. Okay, Java 7, Java 8, right? Heap memory. Okay, what heap memory goes? I said greetings object instance, right? All this the object instance and everything, all the details goes in here. All the it also have a string pool, right? The greeting string, greeting message goes here. Okay, and it's the same in Java 8 version as well. And there's a method area. Okay, class structure of the greetings. Okay, the class structure of the greeting is there, right? This used to go in the method area. Now that is been moved to a meta space. Okay. And method code static, any references to the static variables and all those things used to be there, in the method area. But in Java 7 now those things are actually moved to metaspace in Java 8. That's it. And earlier we used to have a permgen space which stores the class metadata, method code, constant values like strings and all those things. It used to store it, and in Java 8 they removed it. Okay. They put these things in the meta space, metadata, like in the meta space area, and they store the metadata, method code, constant variables, and string reference and all those things. Okay. And meta space, obviously, as I said, it's introduced in Java 8. It's not there in Java 7, obviously. Right. Static memory is the same thing. As I said, it creates a static frames for each method call. Okay. And it stores the details of that um, method level details, or all the different stacks. Say for suppose, if I do one method call, other method call, so it stores the details of one method in a one stack frame. Okay. The same thing happens in the other thing as well. And the last thing is, program counter, it tracks the current execution counter, and handles the native method calls, and uses the NIO, as I said, direct memory, and all the input output operations or whatever. It shows that. That's it, bro. That's pretty much it.